Other Physics 30 group, I'm just going to explain the difference of using this acronym with a diverging lens and a converging lens. So first things first, the mnemonic that we could use is Sir, Nur, Lur, No, Love, SUV. So let's just share my screen to look over this. There it is right there. So first things first, we have to understand what a converging lens is and a diverging lens is. Converging, keep in mind, here's the center point for it. It's basically a lens that has two mirrors, basically concave mirrors put together. And then a diverging lens, a little bit different in that case. Well, we would have to draw basically a convex mirror. There it is. And then the other side of it would represent the split right in the middle, and there's your diverging lens. Keep in mind, diverging lens is always going to be the following acronym part of it, SUV. So it's always going to be a smaller upright virtual, but the rays, how you draw them, is always going to be different parts where throughout. So keep in mind, just it always will have this description of it. So let's get on to some examples here, and hopefully you have a better understanding of how this works. So let's go to the first one right here. So what kind of lens this is, first off the back. So we have a converging lens. So using, second thing, this is our center point. So this can be considered a center point. This is our focal point. So now we need to understand that same thing that's happening with the object now being reflected from that converging lens there. So first things first, so what do we know about the acronym? This is the SIR part of it, hence the fact. What's going to happen is that if the object is here, we have the actual image right over here that's going to be smaller, inverted, and it's real. Because of the fact that the object is in the SIR part. So if you were right, if the object was placed right where the C was, we were going to use the NUR bit of that mnemonic, and then you would get the actual no change inverted in real. So the only, that would be the same size, you would realize there. Okay, let's go to the next one. So in this one, you will realize what's happening here for using, once again, center point. This is your focal point. This is your object. So we are right on the focal point this time. So I'm just going to write all the mnemonic here, sir, and then right on it is ner, and then between them is lur. So we're not in between in this case. And then we have no, and then right between it would be LUV, and then SUV. Okay, so keep in mind, since we're dealing with a converging lens, what's going to happen here is that we're using this one in this case because it's right on the focal point. So keep in mind, what's going to happen here is that there's going to be no image, hence the fact you don't see an image at all. So let's go to the last one here. So what do we have here now? Here's our center point. So what's going to happen here is that it's between the focal point and the actual lens, converging lens that is. So what's going to happen here is we should be using the LUV. Okay, so the L means larger, hence the fact there's our larger. The U is the upright, and it is upright. And then V would mean the virtual, and it is virtual, hence the fact you can't see it. So that's for converging lens. So let's go to a diverging lens now. So first things first, let's look at this example here. So keep in mind what we said earlier, any diverging is always going to be SUV. So you're always going to be smaller, upright, and virtual. So hence the fact, doesn't matter where you are, your object is right here. It's and then you're going to be realizing there's your image. It's your smaller, upright, and virtual. So the next one, here's another example of that. You're going to be realizing once again what's going to happen here when the object gets closer to the lens itself. You're still going to have SUV characteristic of that from that mnemonic, and in there you're going to be realizing that it is smaller, it is upright and virtual. But here's the key for this one: when the image gets closer to the lens, it's going to make it a little bit bigger. And if we went further away, like the previous example, you will realize it's smaller. But regardless, it's both situations are going to be smaller from the original, but you can at least get a bigger image in the end. Just matters how you draw your rays. Make sure you try your best to draw your rays with a ruler to get that understanding of how to draw them. And then you could use this acronym once again, SIR, NER, LER, no love, SUV, to understand how to actually draw it correctly with the correct characteristics of it. Hopefully that helps. And if there's any other questions, don't hesitate to let me know.